everyone. A lot of slides to get through in 30 minutes here, but we're glad to release the OWASP Top 10 2021 after a long gestation. I will suggest that there is another talk that you want to go to if you want to learn about how we made it. So if you have questions about our categories, our data collection, our analysis, and other methods, Brian Glass's talk at a little later today will be a much better talk than this one. This one just goes through what the OWASP Top 10 is. So what is the OWASP Top 10? The OWASP Top 10 is about risks. It's not the impacts, likelihoods of vulnerabilities. It's not about the breach value. So those things are important of themselves. And so if your job is to be a more or less an assurance assessor, it's really, really important that you understand how much it's going to cost. But is this a likely cost? So we do it based on risk, and we've been doing that for a long time. I think most of the ones all the way back to 2007 and possibly even before then were also risks. This is the 7th update. We are a little bit late. Due to COVID, we didn't get as much data in 2020 as we would have hoped for, but we fixed that. The amount of data we got was 515,000 applications. So there's a little bit of chatter on the internet from various folks about our analysis or the ordering. You've got to realize that the OWASP Top 10, it's the absolute bare minimum to avoid negligence. You should be doing all of it. It doesn't really matter if it's A1 or A3 or A10. You should be doing all of it because it is the bare minimum. So please take that on board. We have actually tried very hard this time to make it focus on developers, lead developers and architects, but also as a starting place for framework developers. They really should be using the ASVS because it's testable. You'll see that we've got some changing in order, and that's primarily because of the framework developers taking on board the application security aspects of their, the way that their frameworks work. Obviously, the traditional users of the OWASP Top 10 are AppSec program management, CISOs, CTOs, and so on, AppSec leads, but also AppSec professionals such as penetration testers, code reviewers, vendors, tools, and trainers. Again, we would encourage you to take this as the 101 class that you would give as one lecture at the beginning of the year, not as the endpoint. It's really important that people understand that this is designed primarily to be an awareness piece. However, we have done some work on that. We'll talk about that in a tick. The leadership of the OWASP Top 10 is 4 equals, Brian Glass, Torsten, and Neil. We all write, we all do the data analysis, although Brian does the collection and analysis because he's the data scientist amongst us. We have been working very, very hard over the last few months to get it finished. Many of you have seen the draft, and I would encourage you to have a look at the final version. We'll talk about the way it's delivered in a tick, but fundamentally it is going to be online. I wanted to make sure that it wasn't just a PDF that gathered dust on someone's shelf. It was something that everyone could use. So it's now mobile friendly, and it also allows you to, we will be having a poster that can go on people's cubicle walls once they go back to the office, or if they're working from home, they can just put it up. We want to make sure that it's consumable in a way that it hasn't been in the past. So give it a go. So the highlights. After 20 years, nearly 20 years, injection's no longer A1. One of the things that we had to do was when we looked at the data, it seems like React, Vue, and other frameworks have actually done their job, and people have moved with gusto to ORMs and entity frameworks and whatnot. So SQL injection has gone down to almost, it wouldn't be in the OWASP Top 10 if it was by itself, which is not true of the 2003 and 2004 versions. So we've been combining more and more injections together into the injection finding. And this time we've combined cross-site scripting and JavaScript injection into it as well. And it still didn't make #1. So that's a really good change. And it's actually showing the impact of the OWASP Top 10 over a long period of time. It also says that the original work that Dave Wickers and Jeff Williams did in 2003 has paid off. They had a great deal of foresight and did a lot of work to build that, and they only had limited data, whereas we have like several orders of magnitude more data, and it still agrees quite closely with what they did in 2003. The ordering, it doesn't really matter. It's the 10 things you should be doing. We've deliberately tried to make this shorter by design. We only want you to do them, to learn about the minimum and go up to other things like the cheat sheets and the ASVS or the proactive controls or the MASVS or the web testing guide. We don't want to provide every single little detail in the OWASP Top 10, just simply because we find that as an awareness piece, as a training piece, everybody's got different languages, everyone's got different needs. Let's go and give you the information you really need in a much more greater detail, but the version that you need right now. We've also gone after a new look. You can already see that the OWASP Top 10 iconography at the top right, we have changed that. We also have included, we've given in for a long time. In 2007, I wrote in the foreword, please don't use this as a standard. And of course, it was immediately adopted as a standard. It was embedded into the PCI DSS, amongst others. Please, you know, it's not a great standard. So what we've done is we've talked about the way you can actually use it as a standard, as a very entry-level standard and where to go from there, but also how to use it as a very basic AppSec program. Say, for example, you don't have one at all and you need to get going. What would you do? Well, we have a small chapter on both of those things. We've used the most modern ways of thinking about things to encourage you to have an effective, tangible AppSec program rather than just one that, you know, I think the phrase is, your attacker does not care about your risk register. No, they don't ever look it up before they get going. They figure these things out for themselves. So we want to have something that actually has an impact and actually brings around change. The other thing is that finally, we've normalized all of the titles to be root causes and not symptoms. If you think about it, sensitive data exposure is the outcome of a root cause. So we've sprinkled the sensitive data exposure around the items that it actually includes. And that deduped a lot of CWEs from many of the items that were mixed in the previous version. So it's a lot easier to comply with the OWASP Top 10 now because it has greater focus, because we are looking at root causes and not symptoms. We also have 4 new categories, including insecure design and SSRF. We'll talk about those as we get through. Where are we? We are very, very close to being completely done. As of last night, we were still looking at a PR. We have one more PR to emerge. That won't change substantially the OWASP Top 10 text, so you can actually start using it today. As I said, it's online, so I would encourage you to have a look at it. The one that we're actually looking at right now will increase the clarity of the way that we talk about SQL injections. So it's not going to be earth-shattering, the changes at this point. We also have a number of translations that are in progress, and we've only just started the PDFing and the developer poster aspect, but everything else is done, so we're good. So if you want to learn about how to do it, please use this QR code. It is a risky click, but it's not a Rickroll, I promise. It goes to Brian's talk in Sketch. So you can register to go to his talk. If you want to learn about how it's made, that is the great talk. It talks about how we actually got the data, who we got it from, our methodology and how we came up with that methodology using community input at the Open Security Summit in 2017. We've modified it a little bit based around our experiences of building the OWASP Top 10 2017 and obviously the 2021. It'll be a great talk. Please go. So getting into it right away, broken access control. And you can see here, we've got a picture of a car park and people are just driving around the barrier because, well, there's no fencing to stop you. That is essentially what broken access control is about. When I was doing penetration testing on a regular basis, I would always reserve at least a third of my time to do a comprehensive access control check. I actually did a review of a very famous logistics software used by many governments that run stuff. And it was 17 years old at the time that I was looking at it. And I was able to be an administrator without being logged in. And I could do administrative things without any hesitation. And I was extraordinarily surprised that no other pen tester had ever come across that, and the vendor themselves had never come across that. This is actually incredibly testable. And what we would like you to do is think about things from not just the point of view of breaches, like reading data, but also the unauthorized creation, updating, or deletion of data. It's just as bad. For example, with that software, I could have scheduled maintenance to occur on something that was really quite important that did not need to happen. It could have costed millions of dollars. But more importantly, I could have avoided maintenance occurring on things that needed to occur, and that could have resulted in people dying if it was not done in a timely fashion. For example, if a bridge fell down. So this is an important thing to do. Don't just think about, I can get all the records out. Think about how you can insert new records or modify existing records or delete records and become an administrator. It's really important to test all of those things. This is some of the biggest breaches and largest costs, and I think it's under-tested, so it deserves its A1 spot. Cryptographic failures is a bit of a catch-all for almost anything that has crypto in it, but it's also some facets of sensitive data exposure. It's also some things about, for example, that you don't have TLS set up correctly. This is an area that can be addressed very easily, I believe, through, we're seeing a lot of cloud stuff where configuration is code, and therefore tools can actually help you do a better job. Please start using that sort of technology and using tooling to identify those weaknesses. One of the problems that we do identify in this issue is that people aren't using something that they should be there. Tools never find something that's missing. So unless you're deliberately looking for cold spots, there's every chance a developer and an AppSec professional would both miss the absence of crypto. So do think about how you might find the need to put crypto in and where it belongs. Luckily, injection is still in the top 10, but it is moving down, and it moved down quite a bit. Once we put cross-site scripting and JavaScript injection in, it went up to A3. It would have been probably A8 to A10 without cross-site scripting and JavaScript injection. It is easily, but now very rarely found using tools. But once it's found, it's still as exploitable as it ever was. So please do think about ways that you can improve both your own testing of these things, because it is a bit more challenging to find, but also helping developers adopt better frameworks. If they're still using older frameworks that have cross-site scripting and they haven't yet started the migration path to React or Vue, then they are missing out on automatic cross-site scripting protection. And it is a lot easier to code and test those newer frameworks than the older ones. I've actually been doing some Node.js development around here, and using Jest to test Vue components is dead simple. And I would encourage everybody to get on board with that, because you can actually inject security payloads into that test framework and test it every single build. That's exactly what you need to do. We do talk about the paved road in the how to do an AppSec program. I encourage people to adopt paved roads. This is essentially a set of components that are known secure, or at least well secured. But also it talks about how to make sure that people observe that those changes are still in place. A4 is insecure design. This is possibly our most controversial new addition, but the data is there. So your only choice if you dislike this one is to have more data than us, more than 515,000 apps worth, or a better data analysis. Outside of those two things, and I'm not saying that last one is not possible, that's exactly how Brian Glass became our co-contributor and then co-leader of the OWASP Top 10 2017, because he wrote a 3-part blog series constructively saying, this is the data you have, it can be analyzed in this way, and it shows this. That's exactly what we want to see. If you do have a better data analysis that was using our data, we're more than welcome to take that commentary on. But there is a lot of CVEs about this as well. It's found in 3% of all apps, which is towards the top end, which is why it's so high. We really need people to shift left. I know Jeff Williams' previous talk talked about shifting wrong. My goal here is not to simply just do what we were doing in 1989 and do it in the early stages of the thing. I want us to be working with development teams. It's not precisely scalable, and so we do need to use tooling to make our work a lot easier and better. But it's really quite important that we stop doing things. We are not auditors. Unless you have an accounting degree and actually have majored in auditing, you are not allowed to call what you do auditing. We are not doing desk checks. It has failed. It is a terrible paradigm. We really have to shift left. We must threat model. It's not an option anymore. Even if you're doing penetration testing or code reviews, what would be the weaknesses that this application surfaces to me when I do a threat model? Then I test it. I check my hypothesis. It turns out to be true. Then you'll be able to exploit it. And the great thing about threat modeling is you might spend an hour or two doing it, but then you'll have such exploitable things that there will be no choice but to rewrite part of the application. And this is why we encourage development teams to get into it as well. There's a bunch of threat modeling talks in this 20th anniversary. And there's even more coming up in the November AppSec Global. It's really important that development teams get into this as well, because if the threat models are not there and you've got this vulnerable application and it's vulnerable through and through, it's essentially a rewrite. It is 100 times more expensive to rewrite an application than just simply to design it properly and spend a few hours on each of the major features to make sure you understand where the attacks might come in and what controls you might need, and make sure that they're there and they work. And that means that you've written tests. And that doesn't mean AppSec pros are writing those tests. It means the developers are aware of these issues and they've written tests to prevent them. We obviously want people to adapt better frameworks. Okay, number 5, we are seeing security misconfiguration jumping up a little bit. There's way more than in the previous 2017 data set, and that's because infrastructure is code. And we now have tooling that is actually able to identify a lot of the issues that were hidden from us before. Back in the old days, bad old days, a lot of penetration testing occurred in development or pre-production environments, which weren't the same as production. And so they were often glossed over. You wouldn't actually report on a bad or missing TLS certificate because it wasn't the final configuration. It was literally, this is the development environment. It has no TLS certificate, so you wouldn't even report it. Now we can actually see how the TLS certificate is coming in and how it is configured, what algorithms are there. And we have tools that can actually identify those issues for you. That's why I believe this has jumped up. It is also incredibly easy because of that tooling to address these things. So I do want to see this fall down again, but the only way for us to do this is to surface the risk, to bring this to the attention of the developers as they're building the configuration, the Terraform scripts and whatnot. We want CloudFormation, all of those things. We want them to be built securely. And the best way to do that is run tools over that configuration, identify the weak issues, and make sure that they don't even make it into production, let alone development. Obviously, if you're actually working with the development team and you're building the bathed road and you've got this like golden AMI that you're keeping up to date with a pre-hardened development and production framework components and build configurations, this starts to go away as well. But then you need to make sure that whoever's using the paved road has access to the newer versions as you improve it over time. A6, vulnerable and outdated components. This is by far the largest and most costly breach of all time. It would happen in 2017. I'm not going to rehash that. I think many people are familiar with it. Is covered off in the recent set of executive actions or executive order from the US government. I know that doesn't apply to many of you who are watching this, but I think it's really important that we actually understand that supply chain security is not optional anymore. We need to be able to provide visibility to consumers of applications that what you have done is the minimum, but it also covers off things such as making sure that the build that you're building is the best available, but also that you've used no vulnerable components. We strongly recommend that you use CI/CD tools to warn for outdated components so that tech leads can keep on top of, all that component needs to be replaced or updated soon, and they've got time to do it. But then break the build for vulnerable components. There is absolutely zero excuses in 2021 to have vulnerable components in brand new builds being deployed to production. I know that many of you think, well, that component is not really used in my code, but it's still there. And if you have the option of taking a non-vulnerable component, I don't know why you wouldn't. To my mind, vulnerable components, they may not be exploitable today. Just remember in the past, use after free exploits used to be unexploitable and then they became exploitable. That's exactly the reason why we care about this. We want to make sure that vulnerable components aren't in production systems. Identification and authentication failures has fallen to number 7, and this is primarily because people are starting to adopt OAuth and single sign-on across the board, and by using things such as Auth0 and other cloud authentication platforms such as the Google sign-on, and the Microsoft sign-on, they all have MFA built in. They all have anti-automation. They all have good logging and monitoring. Many of the things that are problematic that are dealt with in ASV2 and V3 are dealt with automatically if you adopt those more secure cloud-based frameworks. What we want to do is, for everyone else who hasn't quite got there yet, or still has the option of having usernames and passwords, that you start to address some of these major issues. And that's why this is still in the OWASP top 10. We also do cover off some of the session management issues, such as session fixation, which is surprisingly still there. I would have thought the frameworks would have helped fix that up. So what I would suggest is have a look at the ASVS. That's aligned with NIST 800-63. Our controls are almost a one-for-one for the NIST 800-63. So if you do the ASVS level 2 and you are using NIST 800-63, you are doing a really good job. You far exceed the requirements of ISO 27002. The one thing that I'll continue to harp on about is please stop doing password rotation. That is an ineffective control. It was ineffective in 1979 when it was first, the first paper talking about it. They broke it in 1979, and yet it became one of the major ways of preventing people reusing passwords. It's a crazy, crazy control because even in that paper, they dissed it as a weak control. Please stop doing it. It's not permitted in the OWASP top 10. It's not permitted in the ASVS. It's not permitted in NIST 800-63. It's not even mentioned in ISO 27002. Please stop doing it. It's really important. I get really head up about that one. Also, questions and answers. The problem is that you go to Facebook, you log on, and half of your friends are answering questions about what the high school mascot is. I mean, that's the reason why this is crazy, is that just because you know something like the high school mascot doesn't mean that you are Andrew Vanderstock. That's as simple as it gets. The evidence of identity, which is why we call it identification and authentication phase, the evidence of identity of questions and answers is negligible. There is none. Just because you know my birthday is not a secret. I invite people to my birthday party. If I had to rely upon the operational security of all of my friends, I would have been breached a long time ago. I always answer rubbish and random questions for those. A8, software and data integrity phase. We are also looking at this as a new one. We want to make sure that accountability is a part of this. We want to make sure that the integrity of the build process is there. A lot of the recent attacks have been nation state attackers, including additional code into an official build. You should be making sure that your official builds are secured. So is there a way to make sure that when you build, what you built was actually correct? It'd be really good to have some sort of process that builds it normally, and then from time to time, you have an alternative air-gapped mechanism of building the same thing and making sure that the two outputs are the same. It is a little bit paranoid, but it's one of the things that we care about. We also care about things like software updates without integrity. And for any of you who use like Visual Studio Code or Discord, you know it updates itself all the time. And it's just an Electron app. It's just JavaScript that's been downloaded to your computer and run. If someone can give you a hostile component without integrity and you don't know about it, then you've lost control of your computer. We want to make sure software updates are done in the most secure way possible. As this is such a new idea, a new item, please do read this section. I'm going to be in the questions section in Slack for pretty much all day. So feel free to hit me up and ask me questions about this new one. Security and logging monitoring failures is our first survey question. For the second time in a row, we've actually asked the industry to participate. We actually extended it out to LinkedIn and Facebook this time, not just Twitter. So we actually managed to get a lot more answers this time. And security and logging monitoring came up as the #1 item. So this was the controversial one in the 2017 version, and now it's the #1 item that everyone wanted in the 2021 version. So I'm very pleased by this. The idea that in 2021, let alone 2017, that you don't want to know about if your application's breached, that you don't want to make sure that your application has an effective escalation procedure is mind-boggling to me. So I would encourage you to include this. There was a great talk a couple of talks ago on what does good logging look like. If you didn't catch that, we hope to have the videos up for members shortly. Do have a look at that. It's really important that logs contain security issues, such as someone's trying to log in a lot. Do you want to have a look at that? Then you can look at it and then identify through logs that someone really is trying to do something, and you can actually take action. It is very difficult to dynamically test this. And going back to that thing about we're not auditors, well, one of the things in auditing is after you're done, you can ask questions. You can interview people and say, hey, did you notice me? I was busy hacking your system for 2 weeks. At any time, did your system alert you? And if so, what would you have done about it if you didn't know it was me? You can ask that question from a penetration test point of view. And that's what we encourage people to do, is to ask questions. It's perfectly valid. If you're doing an ITGC audit and you are an accountant with a CPA, that's exactly how ITGC audits occur. You ask questions and you get evidence for those questions to back up the assertions being made. A10, server-side request forgery. And thank you so much to Orange Desai. He's the world-renowned expert of SSRF. If you've not actually seen any of his videos on SSRF, be amazed. They are mind-blowing. You absolutely 100% need to start following him on Twitter. Check out his Black Hat and DEF CON presentations on SSRF. He's also got a lot of things to do with URL parsers and the way that they break. So absolutely, this is one of the guys that we wanted to have write this section, and he wrote it for us in no time flat, and I'm really, really pleased with the outcome. We edited it lightly, but fundamentally it's his words, so you know that what SSRF is about and how to prevent it. And what we would like to do is make sure that frameworks protect against SSRF by default. This is their job. They shouldn't be allowing this stuff to occur. But it's also your job to make sure that there is segmentation and alerting to make sure that if something unusual is happening, it either doesn't work at all through segmentation, or you're alerted to something unusual happening from a component that should not be happening. But also, we would like to see frameworks, including this function or this method has the potential for SSRF. Please don't pass user-supplied input into this function. It'd be really good for them to do that, but they don't. I would love to see that happen, though, through RustDoc, GoDoc, JSDocs, whatever the case may be. We would love to see that documentation come through and certain your API so that developers are 100% aware of the issue. Running up on time here, so we also have next steps. Please do go ahead and read that. There's always things that didn't quite make it. This time we've actually documented what those are. And also some CWEs you may want to look into. The number one issue is code quality issues, which you can identify using standard tooling for developers. We definitely want to make sure that people are picking those up and dealing with them. But also you can see memory management errors are starting to creep back in. And I believe that's because of Rust and Go, which are generally considered memory safe languages. Because they're systems languages, you can still shoot yourself in the foot, and there's still potential for things like integer overflows, even on Java. So, wrapping up, we want the frameworks to help eliminate bug classes. Please continue. If you want any help doing that, please talk to us. Absolutely threat model your stuff. There's a whole bunch of AppSec program ideas there. I'll be making this presentation available through our GitHub repo. And at the end, basically, do head over to the project top 10. And there's not really a huge amount of time for questions. As I said, I'm going to be here for a long time. Please go to the 20th anniversary flagship project. And ask me additional questions there. We're also, the entire leadership team is in the Project Top 10 Slack channel, and you can ask us questions there at any time. And of course, you can log issues and bugs at our GitHub repo.